name is Ishan, and I'm resurfacing on YouTube after 2 months. And this is because, well, I've been doing some research on the STEM Talk video I made 2 months ago because, well, I wanted to know more because stopping at something so basic was kind of boring. And so, just a quick recap on my STEM Talk video. I learned that in a brain, sorry about my bad drawing skills, by the way. Let's say this is a brain, and this is a spinal cord. So, what essentially happens is you have a whole bunch of ions in your brain. And you take an MRI scan. What occurs is radio waves enter. These radio waves align these ions in a certain configuration, pointing in one direction due to the electromagnetic field imposed, which there are a few basic laws of physics, which I may list in the description. So once these are aligned, you can detect radio waves that are emitted, and what you have is a mapping of a brain. And this mapping of a brain can be matched up with the emotion that someone is currently thinking of, well, while they're having the MRI being taken. So what you have now is a matching with a map of the brain and an emotion. So you know how an emotion looks in someone's brain. Now, what you can go from here, or where you can go from here, is you can take both of these and make many more of them, and what you have is an interpretation of a human, but a computer. And that, I thought, was pretty cool. So, where can we go from here? Well, there's a slight problem. Computing a lot of emotions at one time is pretty tough. So, emotions don't happen like happy, sad, that's it. That's not real life. You have a spectrum because of how many neurons there actually are in your brain. There's a spectrum. It's not just happy and sad. You could be mad. You could be disappointed. Yeah, that's just the first emotion that I thought of off of the top of my head. Disappointed. But you could have many more, and this could add many more dimensions to your calculation. So how do you calculate all of these results? And how do you make an AI able to think fast enough to be able to display these results? Well, this is where you encounter a problem. But there is a way to think faster than the speed of light. So really long time ago, Einstein said that light speed is the cosmic speed limit. Well, there is this really weird quantum theory called quantum entanglement. And why I say this is really weird is that when two particles collide, like an electron and a positron, and they're fused together with gamma rays, what happens is that they become entangled. So they have inverse spin. And essentially, what inverse spin means is that when one spins this way, the other spins this way. And no matter how far apart they are in the universe, when one spins one way, the other spins the other way. They're entangled forever. Which is really weird, because this is breaking the laws of physics. These are staying in the same state, or having the same motion, but are communicating with each other way far across the galaxy in an infinitesimal amount of time. So, how does this work? Well, there are many theories. Some say parallel universes. But that's not what I'm concentrating on. I want to focus more on the fact that this can be implemented into technology that wants to quickly analyze stuff. So running quick analytics. So what you can do is, well, here's a better representation. So you have a normal computer chip. I'm just gonna pretend like it's reading everything encompassed by this space. This is binary, what a regular computer reads in bits. So bits. Well, what's the difference between this and a quantum computer? Well, let me put it to you this way. In a quantum computer, instead of this, you have a quantum chip, and since these particles can exist in multiple states at once, this can be 1 and 0 simultaneously. Now, how does that occur? That still baffles many physicists, but there are many theories in complex quantum physics, which I may explain on a later day, but this is just my fundamental research over the past 2 months. So these can exist in multiple states in every possible combination. So essentially, when you have, let's say, 2 to the 5th combinations for 5 binary digits, you have 2 to the 5th to the, it was either 10th or 100th combinations for a quantum chip. And this increases exponentially. So what you now have is something that can compute faster than light and has many combinations for many possible emotions. Alright, so this is pretty cool, but there's a slight problem. And by slight, I mean a problem that we can get over, but makes making a quantum computer chip extremely difficult. So let's say you have quantum computer chip plus minus particle, positron and electron. And so when unobserved by human eyes, when there's no contact, then the whole quantum entanglement thing works. But when people are observing this, then they just behave like regular particles. They don't entangle, nothing happens. So it's like they're watching us and making sure that we can't see them behaving like this, which is really weird, but there is still scientific evidence for entanglement being true. So how do we do it? Well, we're not looking at it. Well, it's going to take a lot of work, but we can achieve that with modern scientific theories. So now that we have quantum entanglement down, quite a funny name and quite a scientific name. Alright, so now let's move on to the next thing. Now you have MRI detecting the brain, having emotions mapped with, well, brain mappings. Sorry about my bad handwriting. So now you have these mapped, but there's so many combinations that use a quantum computer chip to read all of these. And now you have all of your emotions that the computer can read, and there you go. You just made yourself a quantum computer that can function as artificial intelligence. In fact, many companies and big industrial corporations have predicted that by 2028, we can have an artificial intelligence that is better than humans at everything. Not just calculating stuff or doing chores, at everything. Humans are inferior to artificial intelligence at everything. Now this sounds a bit scary, like Terminator style, but we can go a long ways with this. We can probably find an exoplanet that is inhabitable and have a strategy for inhabiting it by the end of the 2010s, I guess you would call it. By 2020, basically. So now, where do we go from here? Well, first off, I want to try applying for some research institutes to work in some labs, try to make this quantum chip so it's actually possible to make the artificial intelligence. But other than that, this is what I plan to do. And this is our future, this is everyone's future. And this is just my first research vlog. I plan to update this every month to tell, well, everyone out there who's listening about this amazing concept map thing. I don't know. It's cool. But yeah, there you go.